Yeah, welcome to Bookit Academy. Today we are going to be delving into the world of calculus, and one of the aspects of that calculus is what is called the partial derivative. And what is partial derivative? Partial derivative is a derivative we get when we differentiate a function with respect to a variable, keeping every other variable that is not what we want to differentiate constant. So the question is, why partial derivative? Well, partial derivative came as a result of the fact that we want to differentiate a function that is implicit in nature. So for example, if we have a function that is given by an equation given by this such that we have a function of two variables which is equal to 2xy squared plus xy. How do we how do you how do you separate the independent variable from the dependent variable? In this case, we cannot exactly distinguish the independent variable x and the dependent variable y. That is, can you make either x or y the subject of the formula? So you can pause the video and try this and see if you can make this equation the subject of the formula. Now we are talking about partial derivative. Since partial derivative has to do with differentiation, the question is, if we are talking about implicit functions like this, whereby we are having two given variables, x and y, what type of differentiation are we going to be carrying out on such an equation? We are looking at a type of differentiation called the total differentiation, whereby we have to find the gradient of this equation, dy dx. And another type of differentiation we can carry out on this equation is called the partial derivative, whereby we have to differentiate x, keeping every other variables like y constant, or we differentiate y, keeping every other terms that are not y constant. So that is just the idea of partial derivative. Now, we are going to, before we go into the examples, we are going to be looking at some of the notations and higher order derivatives that we can find on partial differentiation. So in this case now, we have this expression here indicates the f, the x, means that we should partially differentiate the function that is given to us with respect to x. This is when we are working with a function of two variables. So its derivative are given by, so the derivative, the partial derivative of the function with respect to x is also written as f subscript x, where the subscript of the function indicates a partial derivative with respect to x. And if we have the f, the y indicates that we have to differentiate the function with respect to y, given the presence of two given variables. So this is also written as f subscript y. Then when we go further to higher order derivative, we can see cases whereby we have to partially differentiate a function twice. So in this case now we have det the x of the f the x. What does this mean? It means that we should differentiate the function f with respect to x, then differentiate the function with respect to x again. So we can express this to be given by, we can express these two other partial derivatives to be given by the 2f over the x squared. That is the 2f the x squared. This is what it is. And we can also express this second order partial derivative to be given by f subscript x, indicating that the function has to be partially differentiated twice with respect to x. Now, when we go further, we have here to be given by the y of the f, the y. What does this mean? It means that we have to differentiate the function with respect to y, then differentiate the function again with respect to y, so that we can properly express this to be given by the 2f over the y squared. And this is also written as, the same way we wrote this, we can also express the second order derivative with respect to y twice as f subscript y. That is it now. So I believe you can also do this for this other derivative. So we have here to be det the x of the f, the y, means that first differentiate the function with respect to y, then differentiate the function with respect to x. So please, when we use the word with respect to, it is always found at the denominator. So this d, this there, and the there at the denominator, they are different. The numerator says we are to differentiate the function with respect to x partially, while the denominator implies that what variable are we differentiating the function with respect to? So the f means we are differentiating the function. The denominator there indicates with respect to what variable. So in this case, with respect to y. So we can write this to be given by, this is equal to the 2f over the x, the y, and this is equal to, we can express this like the way we did this to be given by f subscript x, y. That is for this now. So I believe you all can do this one. It is very, very easy. We can express this to be given by the 2f over the y, the x, and this is equal to f subscript yx. So whenever you see this work in your work of calculus or in your mathematics pursuit, all you just have to understand is that the subscript of this f with the given variable indicates a partial derivative with respect to the subscript variable. So that is that now. And one thing you have to understand from partial derivative is that whenever you have, for example, that the 2f, the x, the y is the same thing as the 2f, the y, the x. So it means that if you differentiate the function with respect to x, then differentiate it again with respect to y, it is the same thing as when we differentiate the function with respect to y first, then differentiate again with respect to x. That is what it means. And this implies that f subscript xy is the same thing as f subscript yx. That is how this works. So we are going to be looking at this given example, and this should help us to understand how partial derivative works. So let us look at this example now. So the example says that if we have a function of two variables, x and y, that are implicitly expressed such that the function is given as x raised to the power of 3 plus x raised to the power of 2, y cubed minus 2y raised to the power of 3. Find f subscript x means that we have to differentiate this function with respect to x. So let us do that first now. So we're given the question to be given by the function f of x comma y is equal to x raised to the power of 3 plus x raised to the power of 2, y raised to the power of 3 minus 2y raised to the power of 3. So now the first part of the question demands that we should differentiate this function with respect to x. So this is given as f subscript x. This is the same thing as the f, the x. That is what it means. So what does it mean? It means that we should differentiate the function partially with respect to x, such that every other variable that are not x should be treated as a constant or as a number. So let us do that now. So in this case, we are going to be differentiating x raised to the power of 3, applying the power rule. So if we differentiate x raised to the power of 3 with respect to x, we are going to be having this to be given by applying the power rule. When our 3 multiplies the base, we have this to be 3x raised to the power of 3 minus 1. That is going to give us 2. Plus, in this case, we have it to be x raised to the power of 2, y raised to the power of 3. What do? We want to differentiate this term with respect to x alone. But if you look at x raised to the power of 2, you will see that x raised to the power of 2 is multiplying another variable, y to the power of 3. So what do? Since y is attached to, is multiplying x, we are going to be treating this y as a constant. So we are going to be differentiating only x raised to the power of 2. So in this case now, if we differentiate this, we have this to be given by 2x. When 2 multiplies the base and you subtract 1 from the power, we have that to be 2x, y raised to the power of 3. So y is not affected because it is a constant in partial differentiation. Now, minus 2y raised to the power of 3. If you look at this this is a variable with respect to only y, and you want to differentiate y, 2y raised to the power of 3, with respect to x. How do you differentiate a function or a term with respect to what it does not have? So it means that if you differentiate 2y raised to the power of 3 with respect to x, we are going to be getting 0 in this case. So this is the partial derivative for this given function. So let us go to the next question now. This is given by f subscript y. This implies that we are to differentiate the function f partially with respect to y. That is the expression. So this is equal to, going back to the original function, we have that to be x raised to the power of 3 plus x squared y cubed minus 2y cubed. So we want to differentiate this with respect to y. So to do that now, if you look at x raised to the power of 3, we can see that x raised to the power of 3 does not have any terms in y. So it means that when we differentiate x to the power of 3 with respect to x, that is going to give us 0. So this is going to give us 0. Plus, in this case now, we want to differentiate x squared y raised to the power of 3. When we run the partial differentiation with respect to y, we have to treat x squared as a constant because that is not what we are differentiating. So in this case now, we are going to be differentiating y to the power of 3. So that is going to give us 3x squared times y raised to the power of 3 minus 1. 3 minus 1, that is going to give us 2. Minus, in this case now, we have to differentiate 2y to the power of 3 with respect to y. So applying the power rule, your 3 here comes down to multiply the base. So 3 times 2, that is going to give us 6y raised to the power of, subtracting 1 from the power, we have that to be 2. So this is the partial derivative of the function with respect to y. Then we can do that for the other derivatives now. In this case now, for the third question, we have that to be given by f subscript xy. This is the same thing as we have seen, higher order derivative. For higher order derivative, we can express that to be given by, this is usually expressed as the x first of the f the y. That is what it means. So what it means is that first we are going to differentiate the original function with respect to y, then differentiate again with respect to x. But if you look at this now, but if you look at the bracket here, where we have that to be given by the f, the y, this is equal to, the f, the y has already been partially differentiated. The result is given by 3x raised to the power of 2, y raised to the power of 2, minus 6y raised to the power of 2. This is what we have here. So what we are going to do right now is that we would just simply substitute into what we have here to make our results quicker. So coming to this now, we are going to carry out our substitution. So this should imply that f subscript x y, which is equal to the x of the f, the y, this is equal to the x of the f, the y is given by this result. So we just have to substitute. So that is going to give us 3x raised to the power of 2y raised to the power of 2 minus 6y raised to the power of 2. That is this now. So at this instance now, the expression is given by the x of this given expression, which means that we have to differentiate these terms here with respect to x alone, where y and y will be treated as a constant, as a number. So let us do that now. So this is going to be equal to, now if you differentiate this term 3x squared y squared with respect to x, what do we get? Applying the rule of differentiation, I believe you can do this. So all we just have to do is to focus our attention on the variable x, treating y as a constant. So applying the power rule, 2 comes down to multiply 3. We have that to be 6x. Then remove 1 from the power. We have that to be given by 1. So since y squared is multiplying x, we write it just the way it is now. So we have that to be y raised to the power of 2. Then minus. Now, we are going to differentiate this with respect to x. But x is not here. This is just y. And according to partial derivative, since we have to differentiate this with respect to x, it means that y is a number, y is a constant. So when we differentiate this, that is going to give us 0. So it means that the partial derivative of the function with respect to x and y is equal to 6x y raised to the power of 2. So let us do that for the next question. So the next question is given by f subscript yx. This implies that we are going to differentiate. This implies that we are going to differentiate the function. This implies that we have that to be given by the y of the f the x. This is what it means now. Sorry about the brackets. So let us do that now. So what it means is that we are going to be differentiating this function with respect to x, then that same result that we have gotten, differentiate it with respect to y. But if you look at the f, the x, we have already gotten the results initially. So we can go on to say that, but the f, the x is equal to the f, the x. The f, the x is actually equal to this now, which is 3x squared plus 2xy cubed. So we have that to be 3x squared plus 2xy raised to the power of 3. That is what it is. That is what we have here now. So all we just have to do is to substitute into this expression now. That is, wherever you see your df dx, replace it by what we substitute it into this bracket. So this should imply that our result is given by f subscript yx is equal to the y of the f the x is given by this. So we're going to substitute. So that's going to give us 3x raised to the power of 2 plus 2xy raised to the power of 3. So that is the expression. Now we should partially differentiate this with respect to y so that all terms that are not y, like x, will be treated as a constant, as a number. So in this case now, this is going to be equal to, now there is no y in the first term. This is 3x squared. Since there is no y, if you differentiate 3x squared with respect to y, what do we get? I believe you got the answer. So that is going to be 0. So we have that to be given by 0 plus, now we have 2xy raised to the power of 3. Differentiate this with respect to y partially, that is going to give us, so we know that 3 comes down to multiply the base, so that 3 times 2 is going to give us 6. X is multiplying them, so it doesn't change, and we have that to be y raised to the power of 3 minus 1 from the root. We have that to be given by 2. So it means that this implies that our f subscript yx is given as 6xy raised to the power of 2. So as you can see now, it shows that the partial derivative of the function with respect to x then y is also the same thing as the partial derivative of the function with respect to y then x. So the result is equal to what we have shown previously. So let us complete the last part of the question. So it says that evaluate the partial derivative of the function with respect to x, where x is equal to 2 and y is equal to 1, and f subscript y when x is equal to 2, since we're given x and y, the variable x is equal to 2 and y is equal to 1. So we can go on to say that hence we have that the function partially differentiated with respect to x when x is equal to 2 and y is equal to 1 is equal to, remember, the function is given by, the function f subscript x is given by 3x squared plus 2xy cubed. So we have that to be given by 3x squared plus 2xy cubed. So that is what we have now. So all we just have to do is to substitute. So when we substitute now, wherever you see x, substitute it, replace it with the value of 2, and y, the value of 1. So that is going to give us 3 open brackets. X is given by 2, 2 raised to the power of 2 plus 2 open bracket. The value of our x is given by 2, so that is going to give us 2 open brackets. Y is 1, so we have here to be 1 raised to the power of 3. So this is going to be equal to 2 squared is going to give us 4 times 3, that is going to give us 12, plus 2 times 2, 4, times 1 raised to the power of 3, that is 4. So we have that to be given by 4. So it implies that the evaluating that value when x is 2 and y is that is given by 16. Then also we have f subscript y of 2, 1. This is equal to fy is given by fy is given by 3x squared y squared minus 6y squared. So we have that to be 3x squared y squared minus 6y squared, 6y squared. So we're going to substitute accordingly. So this is going to give us 3 times our x is 2, substituting 2 raised to the power of 2 open brackets. Y is 1, 1 raised to the power of 2 minus 6 open brackets. Y is 1, 1 raised to the power of 2. So this is going to give us 2 raised to the power of 2 is 4 times 3, 12 times 1 squared, that is going to give us 12, minus 6 times 1 raised to the power of 2, that is going to give us 6. So it implies that the value of that function when x and y are respectively 2 and 1 is given by 6. So this is how we can apply partial differentiation on two variable functions, and that is that. So please, at the end of the video, there would be an exercise that you should attempt, so you do well to attempt the question. And thank you for watching. God bless you. Please endeavor to subscribe to this channel, Kids Academy, and God bless you.